Okay, so I'm just going to talk about my flow solution for this F22 case. I've been running this in rhoSimpleFoam and done 1,000 iterations. So you can see that is the solver output there. And it's not fully converged, but it is converging. So these are my residuals over 1,000 iterations. So that seems to be converging quite steadily. And I've got a view of the mesh here. The sort of mesh I've been using has quite a lot of clustering close to the aircraft. So I've used 8 cells between levels in order to get a bit more mesh around the aircraft. So yeah, let's have a quick look at the flow solution. This is the domain or the bounding box, and I go down to F22, zoom in on that. That is the surface mesh of the aircraft. So admittedly it's quite coarse, and I haven't used layer mesh on this particular case, although I'm planning to do another one with a larger mesh in the future when boundary layers will be included. So yeah, this is the solution. So we can have a quick look at some properties on that. So rhoSimpleFoam is compressible. So being compressible, then we can see some changes in the density, which is exactly what we've got here. So the density variation of this flow solution is between 0.4 and 2.4, which is quite massive. But I mean, this test case has been run at Mach 1.5, so that is about 510 meters a second. So that's cruise speed for this particular aircraft. So yeah, that's the density variation on the surface. And we can have a look at pressure. We could use a different color scheme if we want a different type of legend, but that's the pressure distribution on the aircraft. And what I also like to do is to switch that off, go to internal mesh and create a cut plane. Zoom back out, so cut plane, switch off that. So now we're looking at pressure. Actually, let's have a look at this reference. We can include the aircraft geometry there, just to give a bit of perspective. So yeah, that is the pressure distribution. So we can see some shock waves coming out from the aircraft, and switch on density. See density variation. So we can change the range if we want to zoom in a bit on that. So we could put that from, say, 0.8 to 1.6. And then we'd highlight some of the variation a bit better. Now with this particular flow solution, it's quite interesting because when you're running rhoSimple, you have to, well, depending on the test case, sometimes you have to specify limiters in order to keep this flow solution stable. And even after 1,000 iterations, it's still limiting on pressure. So it's got quite a low static pressure, 29 kPa. And you can actually have a look at that in the flow solution. Because sometimes it might be that there's a problem with the cell quality in a certain area, which can sometimes be an issue. So let's just change that range a little bit more. That's probably a bit too much. 0.9. And take a quick screen grab of that. Yeah, so if I get rid of this, get rid of that slice, so just on the volume mesh, then I can do a clip region or a contour, but I'm going to do a clip and change it to scalar, and the pressure is being limited at about 40 kPa. Incidentally, this will show this is quite useful. Oh. That can show you where instantly where the high pressure regions are on the nose and on the intakes. Oh, so if I want to look at the low pressure regions, I would need to go down to 50 kPa, and that's selected everything, so I just need to inside out. And that's quite interesting because that shows us that we've got very low pressure regions right at the back of the aircraft there, at the exhaust regions. So I guess this is where we've got some quite high speed flow just coming around the edges of the exhaust there. And if you want to 50, 45, if you want to have a look at that into more detail, surface with edges, then you can have a look at that. So yeah, the pressure limiting is just something to be aware of in case it's a problem with a mesh or some other issue. But in this case, I think it's just the fact that using a particular solver, sometimes you do need to have limiters in place just to keep the solution stable. So yeah, that's a quick look at the flow solution of an F22 aircraft in rhoSimpleFoam.